Hello everyone, and welcome to Network Playroom. In this video, we're going to look at the Ospf area types and which LSAs are accepted in those areas. I have another video about Ospf area design and router types, so I won't discuss those topics here. But briefly, before I cover these in more detail, there are 5 different Ospf area types, and they are normal area, stub area, totally stubby area, not so stubby area, and totally not so stubby area. And yes, those are really the area names. I will say an important note regarding the normal area. So area 0, or the backbone area, is a special case of the normal area because all other areas must connect to it. So briefly, before I carry on, let's look at the diagram here that I have from Cisco documentation. So in the middle here we have area 0, and on the left area 2, and on the right area 1. Now area 1 says NSSA, or not so stubby area, but I might change that description as I describe the different area types, so don't pay too much attention to that right now. And I've also included the IP address ranges here that I might use at some point in this video. Alright, but back to the topic. So before I discuss the area types in more detail, let's review a few things about Ospf areas. So number 1, an area is a logical collection of Ospf networks, routers, and links that have the same area identification. A router within an area must maintain a full topological database for the area it belongs to. And the router does not have detailed information about network topology outside of its area, which thereby reduces the size of its database. An ABR will have a separate database of each area it connects to. So briefly, for example, this router R6 would be an ABR, so it would have a separate topology database for area 2 and area 0, which it is connected to. Alright, but number 2. So each area maintains its own link state database, and the link state database of routers within the same area must be synchronized and exactly the same. So this is one of the most important concepts in Ospf. The Dijkstra's algorithm behind Ospf relies on all routers in an area having an identical topology. So again, if we briefly look at the diagram, so let's say area 2, for example. So all routers inside the area 2, so R2, R3, R4, and R5, and R6, would need to have an identical topology database for Ospf to work properly. Alright, and then number 3, a network belongs to a single area and a router interface connects to a single area. The area identification must match on both ends of the link. So let's look at R5 and R6 here, for example. So these interfaces would only belong to a single area, and they would have to match in order for these routers to become neighbors. Alright, so what is the difference between the Ospf area types? Let's first think about why the areas are even needed. So the purpose of the Ospf area design is to reduce the number of link state advertisements and hence reduce the size of the topology database that each router must maintain. And you will see this more clearly when we look at the relationship between the different area types and LSAs. But before I move on, I'll show you a list of the relevant Ospf LSAs on the screen here. I have hidden it in this list. So I have a video explaining the LSAs in more detail, but this is a brief summary, so let's go over it quickly. So the router LSA, or LSA type number 1, is created by all routers, and it describes the router's links or networks in the area. And the network LSA, or LSA type number 2 is generated by the designated router, and it describes all routers on that network segment. Then Network Summary LSA, or LSA type number 3, is generated by the ABR, and it advertises inter-area routing information. Then ASBR Summary LSA, or LSA type number 4, is created by the ABR, and it advertises the presence of an ASBR to other areas. And then AS External LSA, or type number 5 LSA, is generated by the ASBR, and it advertises external redistributed routes into the OSPF domain. And finally, NSSA External LSA, or type number 7 LSA, is generated by the NSSA ASBR, and it advertises external redistributed routes into NSSA. Okay, so first let's talk about the normal area. And there are not many restrictions to the normal area. All LSA types except LSA type number 7, which is specific to the NSSA, are allowed in the normal area. So all these 5 LSAs would be allowed in a normal area. So for example, area 2 here. So let's write that here. So LSAs 1, 2, 3, 4, and 5. So let me point out here that router LSA and network LSA are really the LSAs that contain the most information, and they are advertised inside each area, but they do not leave the area. So actually, if we jump quickly to the packet capture to look at the different types of LSAs, so you can see here, if I open up these router LSAs, there's a lot of detailed information here. Well, actually this LSA just contains one network, 10.0.20.0, but my point is that in addition to the network information and the subnet mask, you can find the link type and the metric. And let's look at this one as well. So here's a little bit more information. This is advertising two networks, which are actually different types. We've gone over this in the router LSA video, so I don't want to spend too much time here. But you'll see what I mean in a moment. And also, if we open up the network LSA right here, so you can see that the designated router is advertising the attached routers, or it's telling which routers are attached to this network segment. So this is very different from LSA type 3, which only includes the network information, the subnet mask, and the metric. So this is why you will hear people say that inside an area, OSPF has detailed information about the topology, but between the areas, it's basically operates like a distance vector routing protocol, because that detailed information is not advertised to other areas. So, for example, yes, ignore the fact that area 1 is an NSSA. Let's assume that this is a normal area. So area 1 would not have the same detailed information that area 2 has, and vice versa. And it's mainly because those router LSAs and network LSAs are not advertised in this direction. LSA 1 and 2 do not go here, whereas LSA 3 does. so the summarized, quote-unquote summarized information, which doesn't mean that it is an actual summary route. It just means that those topological details are lost when you move the information from one area to another. All right. Oh, and actually another thing that I should point out here. So a normal area has the ability to redistribute external routes into that area. So here we have this RIP domain. So these routes would be advertised as type 5 LSAs or AS external LSAs into this Ospf area 5. And because this router would then become an ASBR, since it is doing the redistribution from RIP to Ospf, then an LSA type number 4 would also have to be created, because that would advertise the presence of an ASBR. So then, I don't know, this is getting a little crowded here. So that is why all these 5 LSAs are allowed in a normal area. All right, that got a little messy there. Let me get rid of some of the information here just to make some more space for the next topic. Okay, so before I actually move on, let's now change area 2 as a stub area. So this is a stub now. Alright, so with the stub area, it is not necessary to maintain a full link state database. So if you look at the diagram, the only way for this stub area to reach other areas or external networks is through the ABR. And actually, let's ignore this part here as well. This one does not exist right now. So the only way for area 2 to reach other areas and external networks is through this area border router here. So therefore, the area does not need full routing information. And by configuring a stub area, you can actually reduce the amount of memory the routers use to maintain the topology database. So routers within a stub area receive inter-area routes, which are advertised in type 3 Network Summary LSAs, but rely on a default route originated by the area's ABR to reach external destinations. So what this also means is that LSA types 4 and 5 are not allowed in the stub area. So basically you still have a router LSA and network LSA, because you will find those inside all different area types. But now you can still have inter-area routing information. So you will still find LSA type number 3 inside the stub area. But now, since I've crossed over this RIP domain here, so LSAs type number 5 and 4 are no longer allowed. So it is no longer possible to redistribute those external routes. So you can't have another routing domain connected to a stub area. But as mentioned, LSA type number 3 would still be allowed. So let's say that area 1 advertised this route 192.168.0.0/16. It would still be allowed in area 2 as a type 3 LSA. LSA 3, and it would be like this. And also a default route could be advertised because all traffic would go through this router 6 anyway. Okay, so a stub area is effectively an optimization of the Ospf area design, because if you think about it, again, the whole point of the area design is to reduce the number of LSAs and the size of the topology database. So the stub area takes normal area design one step further by not accepting external routes and using a default route instead. So if we think about it again, before area 2 was a normal area, and it accepted all these 5 LSA types, but now LSA types 4 and 5 are no longer accepted, so that already reduces the size of the topology database. So only 1, 2, and 3 are accepted in a stub area. But is this the most optimal optimization? Now I know that sounds funny, but what I mean is, can we find a way to reduce the number of LSAs and the size of the topology database even further? And the answer is yes. The totally stubby area takes the topology database reduction another step further. So now let's change this area to type to totally stubby area. So let me just write totally here, although that doesn't sound grammatically great, but you get the point. So area 2 is now a totally stubby area. So the totally stubby area is an extension of the stub area and is in fact the most restricted type of Ospf areas. So in totally stubby areas, the routers receive only a default route from the ABR. No external or inter-area routes are allowed. And the default route is the only type 3 network summary LSA injected into the totally stubby area. So right here, I just described how this route could be advertised into the stub area. Well, that is no longer possible in a totally stubby area. So the only type 3 LSA that it is allowed to go into a totally stubby area is the default route. So I'm going to mark this one with the star because now only one type 3 LSA is allowed into the totally stubby area. So is that clear? And this obviously reduces the size of the topology database tremendously, because you can take out all the other type 3 LSAs and replace them with one default route. Of course, it depends how many type 3 LSAs would have been advertised from other areas, so the size of the Ospf domain is relevant, but still you can see how potentially it could reduce the size of the topology database on a large scale. Alright, but next let's talk about the not so stubby area, or NSSA for short. So let me get rid of some information here again. And now this is an NSSA. Alright, I can leave the other information. So the not so stubby area is also an extension or variation of the stub area. The difference is that the restrictions on the NSSA are slightly more loose. So the NSSA adds the flexibility of being able to redistribute external routes into the area while retaining its other stub area characteristics. So basically the NSSA stands somewhere in the middle of a normal area and a stub area in terms of area restrictions. So the NSSA accepts inter-area routes and what I refer to as quote-unquote local external routes. So here's what I mean. So external routes are normally advertised in Type 5 LSAs, but the NSSA does not accept these LSAs. However, the NSSA still has the ability to redistribute external routes into the area, but they are advertised within the area in a special Type 7 LSA. And when these quote-unquote local external routes are advertised to other areas, they are translated into Type 5 LSAs by the NSSA ABR. I don't know if that made sense, but let's look at what I just described in the diagram here. Alright, so actually let me get rid of this information as well. Oops, I didn't want to scratch out that line there. Alright, so let's assume that area 2 is a normal area again, so that we can make the comparison. So remember before when I redistributed these RIP routes here, they were advertised into Ospf area 2 as LSA's type number 5. Well, now here in NSSA, it's not possible to redistribute external routes in a similar way. I mean, the NSSA still has the ability to redistribute external routes, like here from the EIGRP routing domain, but, oops, we don't want to do that. But this time, they are advertised into the Ospf area as LSA type number 7, which is a special LSA type for the NSSA. And when these routes are advertised to other areas, so when the EIGRP routes would travel to area 0 and area 2, they would be advertised as LSA type number 5, and they would be translated by this NSSA ABR or R7 in the diagram. And why I refer to them as local is because the NSSA does not have the ability to learn about quote-unquote remote external networks like these LSA type number 5 networks that were advertised by R2, these external RIP routes. They would not get to the NSA. No LSA type number 5 in an NSSA. So that's why I call them local and remote. So let's look at this one. So what is allowed in NSSAs is 1, 2, 3, and 7. Okay. So finally, there is the totally not so stubby or totally NSSA area. I know it's confusing naming, right? Like the NSSA is equivalent to the stub area, the totally not so stubby area is equivalent to the totally stubby area, but with the external routing capability. So the quote-unquote local external routes are still allowed and advertised inside the area in Type 7 LSAs and outside the area in Type 5 LSAs, but Type 3 LSA inter-area routes besides the default route are no longer accepted. So totally not so stubby area can handle Type 1, 2, only one type 3 and type 7 LSAs. So now let's imagine that this is totally NSSA. And okay, let me get rid of some information again. So I didn't state that clearly before, but LSA type number 3, for example, this route could be advertised when this was only an NSSA. So this was before I changed it to a totally NSSA. This would be allowed. But now that this is a totally not so stubby area, this is no longer allowed. So instead, the only type 3 LSA that would be allowed is the default route. LSA 3, like that. So again, I would put a star in here to indicate that only the default route is allowed in a type 3 LSA into the totally NSSA area. Okay, now let me get rid of this information, and I actually have a summary of the LSA types that are allowed in each area. So let me hide this diagram and then open up this one. So again, briefly here, like these 5 LSAs are all allowed in a normal area. The stub area removes the ability to handle types 4 and 5 LSAs, so only 1, 2, 3 are allowed. And again, the biggest difference between a stub area and a totally stubby area is that only one type 3 LSA is allowed, which is the default route. And then in the not so stubby area, you can have types 1, 2, 3, and 7 LSAs. And similarly, the difference between a not so stubby area and a totally not so stubby area is the default route. Or, I mean, the lack of other type 3 LSAs. So the default route is still allowed. Whoops. There we go. Okay, so now let's briefly look at how the areas are configured on the router and how the area type is communicated in the hello message. So if you remember, one of the fields that must match between Ospf neighbors for them to become adjacent is the area type. So how does the router tell its neighbors that it is in a stub area? Well, this is done by setting the E or external routing capability flag to 0. And this means that the router cannot accept type 5 LSAs, which effectively means that it is in a stub area where no type 5 LSAs are allowed. And since the type 4 LSA is somewhat dependent on the type 5 LSAs, because if there are no external routes, there is no ASBR either. And similarly, the NSSA area type is communicated in the N flag in the options field. And these two fields are kind of mutually exclusive. So if the N bit is set to 1, the E bit must be 0. So let's look at this in a packet capture. So I have this packet capture open here. We already looked at the router and network LSAs and so on. So let me jump to a hello packet. And okay, well, let's look at here, for example. You can see that the packet was sent by router 5.5.5.5 and it's in area 20. And then let's jump to the actual hello packet that was the Ospf header. So here, this is the interesting information that we want to look at. So I just mentioned that if the E bit is set to 0, so this router does not have the external routing capability, it would be a stub area. Well, here it's set to 1, so this effectively means that this is a normal area. I don't remember seeing in this packet capture a router that would have this bit set to 0 indicating that it's a stub area. So unfortunately we just have to imagine that if you would see this as a 0, it would mean that it's a stub area. So then let me jump to this other packet capture to show you an NSSA. So this is a type 7 LSA, so we already know that this must be in an NSSA because that is the only area type where type 7 LSAs are allowed in the first place. So let's see what we can find in the hello packet. Well, we don't need to look at the header. Let's just jump to the hello packet. So here, let's open up the options field. And aha! Here you see the N bit, which is set to 1. And it means that this is an NSSA. And as I mentioned before, these are kind of mutually exclusive. So if this bit is set to 1, then the E bit must be 0, which it is. Okay, great. All right, let's move on to the configuration. Let me go back to the diagram for that. So the configuration of different area types is simple, requiring an extra line of code. And a normal area does not require any additional configuration. So a stub area is configured with the area ID stub command. And this command is added on all routers in the stub area. All right, so let me make some more space here because it's getting a little too crowded here again. A little too messy. Let's get rid of this information. Okay, so how would we configure a stub area? So let's imagine a area to a stub again. So how it would work is that you would add this command, area, then the area ID, which is 2, and stub. That's it. So you would add that on all routers in area 2. So that would mean R2, R3, R4, R5, and R6, which is the ABR. Alright, a totally stubby area is configured by adding a no summary keyword to the area stub command, and this command is only applied on the ABR. So the only difference between the configuration of a stub and a totally stubby area is the configuration on the area border router. So all routers inside the area would still have this command, but on the ABR you would add a no summary keyword. So only the configuration of R6 would change. Okay, so as I mentioned, the no summary argument is required only on the ABR, and it's because they are the only devices that are allowed to originate type 3 LSAs. And although it won't break the Ospf design to add the command to other routers inside the totally stubby area, it is technically incorrect to configure the option this way. And as long as all devices in the area agree on the stub flag in the first place, it is the ABR's duty to determine whether the area is totally stubby or not. So effectively, R6 defines whether area 2 is a stub area or a totally stubby area based on this no summary argument. Alright, so similarly, the not so stubby area is configured with the area ID NSSA command and totally not so stubby area by adding the no summary keyword to the NSSA ABR. So let's look at that quickly. So now, instead of the stub keyword, well, actually the area ID is going to change as well because NSSA is area 1. So on all of these routers, to configure it as an NSSA, you would type area 1 NSSA. And if you wanted to change it to a totally NSSA, you would add the no summary keyword on R7, which is the NSSA ABR. Okay, and then lastly, a word about default routes in Ospf area types. So unlike the stub area, totally stubby area, and not so totally stubby area, the NSSA ABR does not automatically originate a default route into the not so stubby area. Oh, by the way, I think I just said not so totally stubby area, and I've said totally not so stubby area before. I use this term interchangeably, not sure which one is officially correct, but I usually prefer totally not so stubby area or totally NSSA for short. So anyway, a default route can be originated into the NSSA by adding the default information originate option onto the area ID NSSA statement. All right, so let's just recap what I just said. So a default route is not created by default for a not so stubby area, but this can be done with the default information originate command or argument. Let me show you soon. Default information originate on the NSSA ABR, so router 7 here. And there's a nice Cisco document called How Does OSPF Generate Default Routes explaining this. And I should have it open here, so let's have a look at it. So first, this document describes the types of OSPF areas. And here we go. So the first line, normal areas. By default, in normal areas, OSPF routers don't generate default routes into their routing domains, even if one exists. To have an OSPF router generate the default route, use the default information originate. And there are several different options that you can use in this command to generate that default route. So a normal area does not generate the default route by default. But then let's look at the stub and totally stubby areas. So in stub and totally stubby areas, the ABR to the stub area generates a summary LSA with the link state ID 0.0.0.0. This is true even if the ABR doesn't have a default route of its own. In this case, you don't need to use the default information originate command. Okay, so here you can see that the stub and totally stubby area create the default route automatically, and there is no need to use the default information originate command. But now here is the difference. So the APR for the NSSA generates the default route, but not by default. To force the ABR to generate the default route, use the area ID NSSA default information originate command. And then if you look at under the diagram, it says another way to advertise the default route inside NSSA is to use the area ID NSSA no summary command. So with the no summary keyword, the NSSA ABR will not advertise the inter-area routes. Inside the NSSA, instead it will advertise a default route. This default route will be propagated inside the NSSA as type 3 LSA. So I recommend that you read through this document because it has important information about the default routes in different area types. But that wraps up the topics in this video. I hope you found this clear and informative. Send me questions in the comments if something wasn't explained well enough, and I'll try to cover it in another video. But thank you again for watching, and I'll see you in the next